Okay. So here, you two chemists in the 1800s. This is Meyer and Mendeleev. Meyer is German, Mendeleev is Russian. So we got Meyer and Mendeleev try to determine a connection between the mass of an element and its chemical properties. This is still 5-1. Now, I want to ask you guys something. Well, I'll take bio. When you hear of evolution, what's the first scientist that comes to mind? Darwin. When you hear Mardi Gras, what's the first city that comes to mind? Okay, New Orleans, someone said. When you hear, let me think of one more. Let me see. I don't know if I can think of something on the top of my head. I don't know. I can't think of anything on the top of my head. What I'm trying to get at is whenever we think of someone or something, we think of the first person to do it. Darwin was the first person to publish his work on natural selection. New Orleans has the largest Mardi Gras celebration in the United States. No one ever remembers number 2. That's the thing. In my AP Bio class, I teach my students who like the runner-up to Darwin is. His name is Alfred Russel Wallace, by the way. You don't care about that right now. Well, between these two scientists, one of them is far more famous than the other, despite the fact they both had their same work, because one of them published his work before the other guy. Darwin, in natural selection, he had figured out that life changes over time. And he just kind of sat on his work and he kept it until he got a letter in the mail from this guy named Alfred Russel Wallace, who was asking Darwin, I heard about your voyage on the HMS Beagle and your work with natural selection. I went down to Southeast Asia and I observed the same things. And before I published my work, I wanted to just run a few things by you. This terrified Darwin because he thought, oh my God, someone is going to publish their work before me. And we only remember number 1. So Darwin got off his butt. He published his work before the other guy could. And now we call it Darwinian evolution. You guys learn about it in school. You don't remember the other guy. Well, between these two, they both came to the same conclusions, but one of them is credited with accomplishing it before the other, more than the other, because he published his work. So Mendeleev, the Russian, is given more credit for this connection between atomic mass and chemical properties because he published his work first. That's all. Madeline, you know the Bucks won the Super Bowl a few years ago, right? Who'd they beat? Exactly. Well, I know that you know that, but I'm just asking the casual person. You guys know. The Bucks won. They were considered the best. All right. Well, who'd they beat? Right. Oh. That was their first. That was their second Super Bowl. Who they beat in their first one? 2002. See? Nope. The Raiders. I was a junior in high school when that happened. Bottom line is here's one more. New Orleans has the biggest Mardi Gras celebration in America. What's the second biggest? And don't say Universal Studios. Don't say Tampa, because that's not Mardi Gras. See, no one remembers. It's St. Louis, Missouri, by the way. So my point is Mendeleev got a lot of credit, way more credit than Meyer did, just because he published his work first. Also, Mendeleev noticed that when elements were organized by increasing atomic mass, there was a periodic pattern there. That term is again. And their properties. So this kind of helped what's his face? Newlands. He wasn't around anymore, but this kind of gave him vindication. It's kind of like when I taught you guys in Unit 2 how Democritus was talking about that the universe is made out of atoms, and they make up everything, they fill in the empty spaces, and Aristotle said you're full of crap, I don't believe there is such thing as empty space. Democritus was pretty much right, but he was finally redeemed many years later by John Dalton. So put a little asterisk here. This proved Newlands was right all along. The only reason why Newlands had his work rejected is because he decided to use the word octaves, which is a musical trend. You know, you play in octaves, how high the pitch is. That's why they rejected him on that. So Mendeleev arranged the elements into columns. With similar properties, or he made a periodic table. And what you guys see over here is that Russian. You can actually see this is written in Russian. That was his periodic table right there. Notice that there are columns. You can see some very similar symbols there. I'll zoom in once you're done writing. He put them into columns based on their common characteristics. So if I'm going to zoom in for just a sec, here are some of them. And they have the same symbols: boron, carbon, nitrogen, oxygen, fluorine, sodium. Look at all these. Obviously, we have way more now than we knew of back then. That's the thing with human discoveries. We tend to find more and more as time goes forward. But this was the early periodic table. He arranged them into columns. And so this was widely accepted. It also predicted the placement of undiscovered elements. To kind of show you what I mean, if you guys were so willing to pull out the periodic table that you have stuffed in your book, I want you to look in the bottom row. I want you to look at this row. Take out a periodic table that's in the books near you. Those periodic tables I gave you, for most of you, especially on that side of the room over here, it's old. And let me see this now. I want you guys to check out the bottom here. This is what I saw when I was in high school 20 years ago. The bottom has all these 3-letter symbols like UUN, UUU, UUB. These were elements that hadn't been discovered yet. I don't know when this periodic table here was made. Doesn't have a year on it, but I can probably tell you this is from the 90s or the early 2000s. If you guys now look at the periodic table up here behind me, we found them all, or we've made them. The thing with Mendeleev's periodic table is he knew there were still elements out there that hadn't been found yet, but based on the characteristics, he knew where they would be placed. And that was a big deal. He could also predict the properties of undiscovered elements. And some of those elements were like scandium, gallium, and germanium. But there was still one teeny tiny problem. And I want to see if I can find it. Where is it? It's up there somewhere. I gotta just hunt it down. There's a teeny tiny problem with Mendeleev's periodic table, and it had to be fixed. So I'm gonna go up. I don't know if I put a periodic table here. Hold on. Let me see if I can find it. No, I didn't. So I have to use your thing up here. Look up here, guys. Mendeleev organized it by increasing atomic mass number, which are these small numbers on the bottom. There's somewhere on here where it kind of goes up, 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 and it goes down. And then it goes up again. Help me find it because I forgot where it is. I found it. Look right here. 58.9, 58.6. That's one area. Look and see if you can find any other place. I know for those of you in the back, it might be hard. Do you see any place where it goes up and then down and it goes up again?
Check around a lot of the 104 through 118.
Here?
Yeah, like it
Okay, 261, 262, 266. Good job. 264. That's a problem. You can't just go up, 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 down. That was spotted where this is not 100% a 100% trend where it's always increasing by mass number. Sometimes the mass number goes down. So this had to be fixed. And that was fixed by this guy, Moseley. So as more and more elements were discovered as time went forward, there was a noticeable flaw in Dmitry Mendeleev's periodic table. So the way to fix it was rather than arrange elements by mass number, Moseley arranged them by atomic number. If you recall from second period, the mass number is protons plus neutrons. The atomic number is just protons. And he noticed that if you put them in order of protons, the problem solves itself. So this solved the flaws. This became periodic law. Which I believe was on your quiz. Elements are arranged by increasing atomic number. And that's what we have up on the periodic table today. From 1 to 118, they're all organized in this map, in this fashion. And that's it for your history lesson on the old school periodic table.